Good afternoon. My name is Steve Bamshebi. I'm the instructor for this CSC 206, 206 Human Computer Interaction. The course unit 2. Then the human computer interaction still remain the same thing. The objective still remain the same thing. Then the learning outcome of this course unit 2 is students are expected to understand handwriting and speech recognition. Students are also expected to identify positioning, printing, and drawing devices, know display devices, then recognize physical and control sensor, and to be able to differentiate between printer and scanner, and to also have the knowledge of memory and storage format. This is what is expected from the students in this particular class. So now let's go to the overview. The concept, the computer system is made up of various elements, and each of these elements affects the interaction in the following manners: input device, output device, then also virtual reality affects various special interaction and display device. And physical interaction also. So, going by the introduction, long ago, going down memory lane, remote computer interaction was done through batch processing involving punch card stats or large data files prepared with long wait for the line printer output. And if it is not right, the wait continue indefinitely. But now most computing is truly interactive with rapid feedback, and the user is in control most of the time, with the thinking taken over by the computer. A typical computer system interaction is carried out through input devices such as the screen, monitor, keyboard, mouse, trackpad. The input device exists in various of desktop, laptop, the input device exists in various of desktop, laptop, mainframe computer, and personal digital assistant. The device dictates the style of interaction that the system supports. If we use different devices, then the interface will support a different style of interaction. The unit set out to remind you of the various nature of human-computer interaction that you may have normally come across. In order to understand this nature of human-computer interaction, one needs to understand the computer system. Meaning you have to at least have a grasp of what computer system is all about before you can understand what human-computer interaction is all about. And I said in the overview, I said input device, for example, are used to test entry and pointing. Then while the output are used to display and print of the processed data. Then we have physical interaction carried out through sound, haptic, and biosensing. Then paper is used for printing out and for scanning input. Storage and memory also utilized through accessing large capacity random access memory and permanent storage, which is added. Then processing is also carried out using high-speed processing unit and networks. You can see the graphic below. This is pictorial representation of what a system looks like. This is your input, which is the keyboard and the mouse. Then you have your display devices, which is your monitor or your screen. And you have the files that are in the system. These are just graphical representation of what it looks like. Then they say most of these common test input devices allow rapid entries. The richer interaction is enabled through faster text entry devices using keyword keyboard code. These are the format of previous keyboard that we have. You can see how it is being configured, backspace, then the numerical, then you have the alphabet. So this is alphanumeric keyboard with space and other function keys. But this one does not contain function keys for you to be able to see the standard keyboard for system. Text entry. The site standardized layout keyboard with non-alphanumeric keys are placed differently because accent symbols are needed for different scripts. An example of QWERTY arrangement is shown above. That is what you see above. Then the second arrangement is not optimal for typing because initial layout was to prevent typewriter jamming. Alternative design, however, allow faster typing, but larger social base of keyword typists produce reluctance to change. Alternative keyboard layout introduced later have the following character alphabet. Here are the keys that are arranged in alphabetical order. Then do rock. This has common letter under dominant finger with bias towards right hand. Common combination of letter alternatives between. So we have several different keyboard that was initially designed before it evolved to the current keyboard that we are using today. Then these are special purpose keyboard. These are designed to reduce fatigue for RIs and also for one-handed use. Then chord keyboard. These have only a few keys, 4 or 5 in numbers. Letters are typed as combination of keys pressed. The key press reflects the letter shape. So these are just a model of keyboard. Then look at the keyboard for a simple phone. You understand? Look at how the key is being arranged. So in the olden Nokia, whereby one has the 3 letters, then 2 also has 3 letters. This is how those keys were being manipulated then. Then numerical key. These are also developed for easier human-computer interaction since they provide means of entering numbers quickly. They could be found in calculator PC, your telephone line, your ATM, and many other keys. So there are 4 keys, up and down. Look at this one too, up and down. And this one you have this kind of key in your keyboard, up, left, down, right. The keys are very, very cheap but slow and provided basic motion for text editing tasks. There is no standardized layout but invented T that is most common with discrete positioning control. Then we have handwritten recognition and other devices. Handwritten recognition. Another initiative that improves human interaction is handwritten recognition. Here, text can be input into computer using a pen or a digesting tablet, thereby producing natural interaction. However, this generates the following technical problem. Difficulties may be experienced while capturing all useful information in a natural manner and segmenting joined up written into individual letter. Also, difficult is interpreting individual letter and coping with different style of writing. They are commonly used in what? In PDA, personal digital assistance. Tablet. So we have speech recognition, history of basic interaction continued. This provides the advantage of leaving the keyboard on the desk, doing some other things and tasks and talking to the computer. meaning that you can actually use speech to carry out operation by using your direct voice to to send signal to the system, and the system will recognize the voice, then carry out the task. Then other devices are classes of human interaction devices are positioning, pointing, drawing, and all that. A mouse, positioning, pointing, and drawing device. Mouse is one of them. So this is a human computer interaction medium and is handheld pointing device that is very common and easy to use. It has two characteristics, the planar movement and the button. Usually from its three buttons on top, used for marking a selection, indicating an option, or to also, we all know what mouse is used for and how it is being used. Main, uh, main textbook. Then we have physical control sensor. Physical control sensor, these are specialized display and gauge control environment and biosensing. Dedicated display like physical control analog representation that include digital display as identified in small head-up display found in a aircraft cockpit. Then sound. Sound are beep, bond, clunk. Confirmation of action, e.g. key, click, touch, feel, and smell devices. Other ear, touch, and feeling are important. Also important in simulation that require, however, current technology. Just like what we see in BMW iDrive. This is used for controlling menu. Wi-Fi option by Fitbit use haptic technology from. Then we have another physical control. These are specialized control that exist. See the example. So most of these things are biosensing and they are very, very effective for physical control. Then we have print technology whereby we have printers. This is an image made from small dots. It allows any character set or graphic to be printed. Critical features are resolution expressed in sizes, spacing of the dots in dots per inches. Speed is usually measured in pages per minute. All of us, we have seen printer before and we know how it works, and it prints with using small dots to get the job done. So type of dot based printer, we have dot matrices printer, we have inkjet, bubble jet, we have laser printer, we have font. So we also have scanner. This accepts paper and converts it into bitmap. Two sorts of scanner exist. We have flatbed, then we have handbed. Flatbed are paper is placed on a glass plate with both pages converted into bitmap, while the handheld here scan is passed over paper, digitizing strip typically to 3 to 4 white shiny light at paper, and note intensity of reflection with color and grayscale. Typically resolution are from 600 to 2400 dpi. Scanners are used in desktop publishing for incorporating photographs and other images. They are used in document storage and retrieval of systems, thereby doing away with paper. Memory interactions. This is another form of human-computer interaction. This exists in form of short-term and long-term. One needs to have knowledge of characteristics of a particular memory for, for an effective and valuable interaction. Such include the speed, capacity, the compression format, and mode of access. Short-term memory. Short-term memory, otherwise called random access memory, are made of silicon chips. Most RAMs have 100 nanoseconds access time and are usually volatile, losing information if power is turned off. Data transfer rate is around 100 megabits per second. Some non-volatile RAM, like ROM, are used to store basic setup informations. Typical desktop computer have between 64 to 256 megabits of RAM. Long-term memory also have bigger size that is ranging into 1 gig, 2 gig, 5 gig, 6 gig, 7 gig, 8 gig RAM and 16 gig, 32 gig, depending on the size of such computer. Then, other storage devices are floppy disks, optical disks, which we all know as CD-ROM or CD drive, CD, then optical disks like hard disk, PDA, personal digital assistant, then we have flash memory like flash drive, and the rest of it. ASCII. This is a 7-bit binary code that represents each letter and character. This is an 8-bit encoding of 16-bit character set. RTF, rich text format. This is text plus formatting and layout information, SDMR, standardized generalized markup language. These are documents regarded as structured objects. XML, extended markup language. This is a simpler version of HTML for web application. The media format. Many storage formats exist from images. Such formats include PostScript, GIF, JPEG, TF, PC, etc. in addition to different compression techniques that reduce their storage requirements. So therefore, lastly, it is unpredictable nature of network. The internet as an example of a network, international network of computer shortly history. TCP, transmission control protocol. This operates at lower level on packets like letter between machines. Then IP, internet protocol. This also provides a reliable channel like phone call between programs or machines. Email and HTTP, hypertext transmission protocol, built on top of this. So, in spite of all this discussion above about various interactions above, some limitations are placed on interactive performance as follows. Computation bound. Computation bound may take a longer time, causing frustration for the user. Storage channel bound. Bottleneck may occur in transferring of data from disk to memory. Graphic bound. Here, common bottleneck is that updating display requires a lot of effort. An effort sometimes helped by adding a graphic coprocessor optimized to take on the body. Network capacity. Though many computers are networked with shareable resources and files and access to printers, etc., yet still have interactive performance reduced by a slow network speed. Summary. The knowledge of computer system and the type of user interface devices, such as the text entry, handwritten and speech recognition, pointing and drawing, display, and storing together with the kind of network facility have their individual impacts on human-computer interactions. So, with this, we have come to the end of this class and hope to see you in the next class. All these things that I have said about computer interaction are things that nearly all of you are familiar with. You have been using them. Probably you have not been paying attention to their importance, how they originated, how their invention came into existence, and how their usage is very, very important to human-computer interaction. So this course is now telling you, is taking you back to the origin of those devices, how they have been invented, and how the technology behind each of them, so that you will not just say, man, yeah, I know the work of mouse. They have taught me from nursery, from KG. They've taught me mouse. Mouse is used as a pointer. The keyboard is an input device. No. The purpose of this course, that what's the essence of teaching us all these things all over again? This is a thing that we know. The purpose of teaching you is for you to add the originated experience of how all those things were invented, and evolution that take place across their inventions, and their importance, and technology that is behind them. So that is the purpose of having this course. So we hope to meet in the next class by grace of God. Thanks for listening. We meet again.